As always, when we've got several forces going on, the very first step is drawing our free body diagram. And I'm going to start with my sign. And for the sign, I know that the force due to gravity is its weight, so it's 198 newtons. And it's supported motionless by 2 ropes. So we have 1 rope that way and 1 rope this way. And they each make a 24-degree angle with the ceiling. So if we're visualizing it, here's the ceiling. This angle has to be 24 degrees because this is visually obviously more than 90 degrees. And so this angle also has to be 24 degrees for the same reason. So this is force of tension 1 and force of tension 2. Now we also know that we can break our tension forces into X and Y's, and we should. That's our FT1X and our FT1Y. If this angle is 24 degrees, then so is this one, because these 2 lines would be parallel. You could also think that this would be 90 minus 24, which in a right triangle would make this 24. Whichever way makes sense to you for that. So this is FT2X and FT2Y. And again, our 24 degrees. So now we're going to decide if it's at equilibrium or not. And I like to mix the second and third step a little bit. Decide if it's at equilibrium in the X direction and write what we know in the X direction. And then do the same in the Y direction. So because the sign is motionless, we know that the sum of the forces in the X direction is equal to 0 because it's at equilibrium in all directions because it's motionless. And in the X direction, we just have these 2 forces. So we know that FT1X equals FT2X. In the Y direction, it's also in equilibrium, so the sum of the forces in the Y direction is also equal to 0. And in the Y direction, we have force due to gravity downwards and these 2 Y's upwards. Now hopefully you've seen that because these X's are the same and the angles are the same, that means the whole triangle is identical. So we know that FT1 is equal to FT2. So we could say FG equals FT1Y plus FT2Y. And since we know that those are the same thing, we can say that FG equals 2FTY. And we know that f of g is 198. So 198 equals 2FTY. And taking that a step further, we know that FTY is equal to 99 newtons. And all this is just from writing what we know and deciding if it's at equilibrium. Now that we have Y, we can plug it into our triangle and solve for our total tension force. And since my triangles above are pretty messy, I'm going to draw a new one real quick. So here's my tension. And I'm going to drop the 1 and 2 because we know that they're identical. And FTY, which is equal to 99. And we know that this is 24 degrees. So since our Y is opposite, we're thinking so, ka, toa. So involves opposite and hypotenuse. So we would say the sine of 24 degrees is equal to opposite, which is 99 newtons, over hypotenuse. And we can do our math. and we get 243 newtons, but when we look back we can see that we only need two significant figures, so we round this to 240 newtons. So we can see, back up on our free body diagram, that the weight downwards is 198. But it is held up with 240 plus 240. It's using a force of a sum of 480 newtons to hold this sign up. And the reason is that only the y portion of this force is actually holding up the sign. If we wanted to be able to use less force on our ropes, like what if they break at a certain tension, then we would need to make our angle greater, because that would then make this side longer and would make more of the tension force be in the y directions and actually doing work to hold the sign.